Hello everyone and welcome back to the fourth Winter Data and AI Meetup. Thank you for joining us today. Our next session is about making ML platform ready for real enterprise use. Our speaker is Alex Kharkevich, Associate Principal System Engineer. Today he will talk about enterprise-grade ML flow, OIDC SSO, fine-grained permissions, and CI/CD. In this talk, we will learn how MLflow can be transformed into a secure and production-ready platform. You will hear about authentication, permissions, and how MLflow can be integrated into enterprise environments. If you enjoyed this event, please like and subscribe to support our community. Your feedback helps us to improve future meetups. If you have questions, please write them in the chat and we will discuss them at the end of this talk. And now let's welcome our speaker. Alex, the floor is yours.
Hello. Um, Hello again. I'm Alexander Kharkevich. Most of my work belong of engineering, leadership, client engagement, platform strategy, and delivery in data-intensive products. Over the years, I had the chance to work with clients across a bunch of different industries, and every project came with its own challenges and lessons. That gave me a view how to DevOps and data engineering come together and how to build resilient, scalable systems in complex enterprise environment. On the side, open projects are one of my favorite indulgence. All right, enough about me. Let's talk about our roadmap for today. A quick overview of ML flow to make sure we're on the same page. Identity and access management, authentication, authorization, and how role-based access control fits into the picture. Next, I will talk you through my own solution for solving the enterprise auth problem. ML flow is an OIDC SSO plugin. Then SDLC quick overview. The next will be a live demonstration. And finally, well, wrap up with your question. I want to make sure that we address whatever's on your mind. Sounds good? Let's get started. The quick housekeeping before we dive in. I am the owner of mlflow-oidc-auth. All features shown apply to the latest open source version. MLflow is a trademark of the Linux Foundation. This presentation is independent and not affiliated with Linux Foundation AI and Data or Databricks. I'm presenting purely in my capacity as the owner of the MLflow OIDC-auth project. With that said, let's get into it. All right, let's start with a quick MLflow overview. If you're familiar, this is a refresher. If not, it's the foundation for what we will build on today. So, what is MLflow and why does it matter? MLflow is an open source platform for managing the full machine learning life cycle, from experimentation to production. In centralized tracking on parameters, code, and metrics make collaboration and deployment easier. MLflow now support two major cases: GenAI applications, observability evaluation version, and GenAI gateway for managing LLMs and points. Traditional machine learning, experiment tracking, model evaluation, versioning, artifacts, model registry, and deployments. Whether you're shipping GenAI application or managing classic machine learning models, MLflow handle both. For more details, you can check on mlflow.org. So, where you can actually run MLflow. You got a lot of options. Locally on-premise and Kubernetes, we are managed service like a Databricks, SageMaker, Azure Machine Learning, or Nebius. Today, we focus on self-hosted MLflow, where you own the security story. Especially, we're going to talk about how to do authentication and authorization properly, how to implement fine-grained access control, how to use OpenID Connect single sign-on, and how to make this all work smoothly in your delivery pipeline. Let's go. Now let's talk about authentication, authorization, and role-based access control in MLflow. Out of the box, the standalone open source MLflow server does not provide built-in authentication or authorization. Anyone who can access the UI or API can see and modify everything. It's really not acceptable for enterprises, especially with sensitive or multi-tenant data, right? So if you're a self-hosting MLflow, you can and you should care about security, right? The first questions you have to answer: how do I control who can access what? That's exactly the problem space we're going to explore next. MLflow support basic HTTP authentication, like a plain username and passwords for all users with server-side permission and admin control. Um, a few pros and cons: built-in access control, persistent permissions, universal support. A few concepts like still experimental, no SSO or OIDC integration, credentials sent on every request, no proper logout or session management, and manual password management. Basic authentication solves zero security, but isn't enterprise ready. It's missing the modern authentication pattern that teams expect for today. The second approach, very common for enterprise, place security proxy, like a OAuth to proxy or ingress controller in the front of MLflow. The proxy handles authentication via OIDC, OAuth 2, or SAML. A few pros: enterprise grade SSO like Okta, Microsoft Entra ID, etc. A float auth complexity, tokens, MFA sessions, TLS termination at proxy. MLflow stays stateless, especially for authentication authorization flow, and flexible for deployment. A few cons: no native group-based authorization in MLflow. Python SDK or CLI require manual token handling for this case. Must trust header from proxy, more complex setup and maintenance. Header harder to troubleshoot, especially for distributed auth flows. So reverse proxy pattern is better than basic auth. You get real single sign-on, but it doesn't solve the authorization problem inside MLflow, and it has operation complexity, which is bring us to the third option. The hero of today's story, mlflow-oidc-auth plugin. This is my open source project, and it brings both SSO and role-based access control to the MLflow in a way that solves a limitation we're just talking about. Strengths: OpenID Connect single sign-on with corporated IDP. As I said before, supported Microsoft Entra ID, Okta, any OpenID compatible identity provider. Centralized identity sync, no manual credentials. Group-based authorization with regular expression-based rules for experiment models for objects inside of MLflow. Works with UI, REST API, and standard client. Secure session and token management. Basic authentication fallback for legacy clients. Trade-off: more complex deployment setup. You need to configure OpenID provider, client ID, scopes, all this stuff. Community maintained, you need to watch for version, for compatibility, for backward compatibility, and so on. Operational dependency on your identity provider, and that's it. So, but here's the payoff. You get enterprise grade security, fine grade access control, seamless SSO, and a clean way to manage permission and scale. It's the right solution, and if you're serious about the securing MLflow in production. Recap. This table compares the three fundamental different security models for MLflow. Basic HTTP auth, minimal local security no SSO, no group level authorization, limited session handling, fine for small teams or sandboxes, not for enterprise scale. Reverse proxy SSO, strong authentication and SSO, but authorization stays outside of MLflow. Not true role-based access control for experiments, models, gateways, and API clients still required workaround. mlflow-oidc brings SSO and group-based role-based access control directly into MLflow. Fine grade permissions at the experiment and model level. Secure token-based access for UI and API enforced inside the application. Modern organization needs centralized SSO, group-based authorization, auditability, and secure API access where the ML access live, right? Among three options on the MLflow, OIDC auth deliver the full package inside of MLflow. Well, I need to take a brace, but we'll cover it. Why securing self-hosted MLflow is challenging and is challenging. Now let's switch gear from theory to quick walkthrough of MLflow OIDC auth, how it looks in the UI, how permissions are managed, and what the developer experience feels like. I think the next part is a guided tour. We'll start from login, user, and groups. Finally, find out how permissions shape access inside of MLflow. Well, after login via OpenID Connect, users land on the personal homepage in the permissions UI. They can see their display name, their username from IDP, the groups they belong to, and user able to press button to create the personal access token and personal access token expiration data. This is key point is that permissions are transparent. User can immediately see which groups they are in and understand why they can or can't see certain resources. To stay compatible with standard MLflow client, user can generate personal access token from their profile. The flow is simple. Choose expiration data, request the token, and use it like a MLflow password in notebooks or pipelines. No code change required from the user side here. Tokens are time limited with maximum limitation in 1 year, which is more secure than static passwords, while remaining developer friendly. For every who allowed to log in into MLflow, we can define a dedicated set of permissions. On the left, you can see the users list. We can pick up any user or service account and open the detailed permission view. On the right, you can see permission for a single user. You can grant, read, edit, or manage access to specific experiments or models, and we can also define the fallback rules. So, for example, user might have managed access to their own experiments, but only read access to shared organization-wide ones. This gives you individual level control when you need exception beyond standard group roles. Now let's look at group permission management, which is where the plugin really shine for organization. At the group, all group automatically propagated from your through the OpenID Connect integration provider via token claims. No manual setup needed here. Your IDP remain the single source of truth here. For the group tab, admins can manage permission at the group level, assign, read, edit, or manage the same. Access for experiment or model based on the naming pattern. Instead of managing 100 users, you can define permission once per group, for example, for data scientists or for machine learning platform team, and someone who belongs to this group can log in through the OIDC and get automatically permissions for object which is accessible for. So, and I recognize this like an enterprise-grade role-based access control, centralized and fully automated. One of most powerful features available for admin users only. This is regular based permissions. Instead of assigning access experiment by experiment, admins can define naming pattern. For example, grant for the finance team manage permission. Finance ML team, and for rest of the users just only read. Works both for users and group. And what is the best part? It's automatic. When you new experiment match the pattern, name-based pattern, permissions apply immediately. No manual intervention required. This is securely that and scales with your organization. Team just following their name convention, and access control just works. No tickets to platform engineer, no waiting for approvals. It's just self-service, self-healing, and fully under admin control. Simple but important slide. Effective permissions follow in a clear hierarchy. The first step is just check for different check for direct user level permissions on the specific experiment model. If none are found, check on group level permission for any of the user groups. If still not matched, check the user regex rule, broad pattern that apply to this user. Then check for group regex rule, patterns defined for any of the user groups. Finally, fall back to global fallback rules that applies to everyone. This makes access predictable, auditable, and make easy to explain, critical for compliance and troubleshooting. By the way, you can configure this order or remove part of this rule if you want in the future. One of special feature was calling out is trash management with permissions. Also, this is admin only. Admin can restore deleted experiment and runs. It's great for data science and data scientists who accidentally delete something. And you can do this in the single way or bulk deletion. Also, it's really convenient. You can have automatic housekeeping in the MLflow, but sometimes you need to do this immediately, and just it's much easier to go to the UI and manage it. Another special feature, webhook management. You can create, edit, or delete webhook from the UI, not from CLI, not from API client, directly from the UI. So you can react through this webhook. You can react to experiment events, trigger external workflow, integrate with CI/CD, Slack, audit system, whatever you want. And this is supported on the full create, read, update, delete, and event-based triggers. One small note here: the webhooks still experimental feature in MLflow, and this feature required only SQL backend for MLflow only, not available in file mode. So, great. We're covered the core plugin capabilities, authentication, role-based access control, regex rule tokens, and production-ready features. Now let's zoom on the SDLC. And our next slide, like this. And what I wanted to say, while preparing this presentation, I realized there is no silver bullet solution. The slide shows one of possible approach, separating multiple MLflow instance and connecting deployments through the intermediate artifact storage. There is no single right architecture. The best design depends on your specific, on your use case, on your use case and your constraint. So anything acceptable. Whew, enough said. Let's see it in action. I walk you through the live demo, login flow, group permission management, and usage with usage in real time. This is real, not pre-recorded session. Bear with me. Here, our application. We can sign up with some kind of OpenID Connect provider. This is faked. OpenID provider created special for this demo session. And here you can see, for example, the user Peter is not have required MLflow users group. He's just member of random group. And try to log in. And you can see here that user is not allowed to log in. Okay, let's try again. And we select right now admin user. When we log it in, we started from MLflow page, go to the permissions plugin, and you can see that we have admin privileges, and we have some kind of experiment with manage permission, fallback permission, fallback the level of permissions for all this stuff. So we can create the access token like this one, check it, hide it, and we can check that nobody else here. You can see that it's only a single user on this MLflow instance for right now. But we can create the service account. Oh, sorry. We can create some kind of demo service account and save and try to get edit permission. Right, let's log out and try to log in with some kind of different user, like Alice. Here on the permission page, we can see that Alice belongs to different groups and still have some kind of fallback permissions. Let's log out, log in under admin, go to the permission, and revoke all permission from Alice. For example, we can see MLflow demo and MLflow default experiment, and right now I want to say no permission level. Oh, sorry. No permission level and prompts, and I would like to hide all prompts and see. Let's do it in another way. For example, Alice. We can go to the group and, for example, grant for group prompt reader in regex mode in prompts, like set asterisk. And this group calls prompts reader, but this will be not. Oh, sorry. I need like this one. It's created. Okay. All right. Let's log out, log in like Alice. And we can see that no experiment over here. Everything is hidden. Let's go back with admin. No, let's create a user Bob. And you can see user Bob by default can manage everything, can play with what he wants to do, can delete experiment run, right? Go to permission. You see that the trash management is not available here, and log out on this level. Back to admin, check our trash, restore it, and then go to the Bob and switch from regex mode and give him only read permission. Okay, here we can log in back. And can see here, let's clear it out like this. Oh my God. Where is it? Application. Network. Yes, finally. And for example, we try to change something in description. And you can see that we get permission denied. And if you refresh the page, nothing changed. All right. What else I want to show you? Probably the last feature here. It's just log in through the admin credentials, go to the permission management, see the webhook, and you can see that we can create the new one webhook. For example, new webhook. Oh, sorry, typo. Add some kind of URL. And for example, when we create some kind of, when we delete some kind of prompt tag, we will receive webhook classification. We can create optional secret like this here. Let's put it webhook. All right, something goes wrong. Let's check it. Let's just prepare a demo webhook, and the echo service we can see here. Just we received like this one body. We also can validate signature. I put the signature here, and like you can see, this is valid. And if we put some kind of random, it's invalid. So this is for webhook management. All right, this is quick overview from demo, and also we can globally change the dark and light scheme. All right, that's it. Thank you. Hold on. Yeah. All right. That's it. Thank you so much. You're awesome audience. I believe you enjoyed my presentation. And now it's time for Q&A.
Thank you, Alex, for this presentation and great demo. And we've got several questions. And the first one is, MLflow is a lightweight tool for experimentation, right? Or is it a full enterprise platform?
It depends on your use case. I would say most of my use cases was covered by MLflow, especially for Gen AI. The latest features are great, like gateway management, Gen AI features. Just really cool. Here, you can create some kind of AI gateway in central way, and this is really cool for the Gen AI application. Probably you can find some kind of your special use case when you need to have different platform or managed solution, but again, you need to have a choice, and this choice just only you. Thank you.
I see. And are there any other alternatives like MLflow on the market?
Other alternatives, again, MLflow right now is probably the major project for Gen AI applications for enterprise management, and probably the better what we can see from the open source perspective. Also, MLflow has great managed solutions from different vendors, but for alternative, I don't think so.
Mhm. Okay, where do you think ML platforms like MLflow will go in the next 2-3 years? What will be improved, or which
Right,
killer features are expected
right now,
in forthcoming
guys.
future?
For the MLflow backlog are open. You can go to the GitHub and check what is planned next. But frankly speaking, everybody knows the directions. We're moving forward. We're moving very fast forward in the Gen AI based applications. Not only some kind of fancy bot who can answer for you in Slack. We are going for real application who help business growth, who helps for in our daily life. And when you build some kind of scale applications which need to be scaled on enterprise grade. For example, the feature like an AI gateway, which is automatically gives you permissions and centralized management point, it's just probably one of the best solutions in the market. So yeah, but nobody knows. Nobody believes in LLMs 5 years ago, not five, probably 8 years ago, but right now we are here and talking about the LLMs.
Yeah, and how do you think what MLflow do very well and where it can struggle?
This is I have simple answer on this question. If you need to have some kind of deep integration, for example, deep integration with Databricks, you have no choice and you have no sense. You need to use some kind of managed solution, right? In that case, you need to manage MLflow. Uh, for rest of the cases, this is this platform has really huge audience and really huge community, and probably again, as I say, this is the best part for enterprise grade systems. But if you looking for some kind of home lab project, like a do your own stuff, you probably skip complications with MLflow and have some kind of direct connectivity to LLMs providers or to your home lab machine learning farm.
I see. And one more question. You have shown individual level access management. Is group list or role level management possible in MLflow?
Yes, here we can see the group, and for example, for the group, we can add experiment and grant some kind of managed permission the same way, like I did for the individual user here. But for group, absolutely the same experience.
Mm-hmm. I see. So it's fully manageable to
Absolutely.
can apply any level of. access. Okay, and the last question for today's session: what is the most common MLflow mistake you see in real projects? A bit provocative question.
I'm just trying to realize I can talk about it or not, but probably uh, I would say this is the great solution with no mistakes at all, right? I would like to
So we are
keep
talking not
I
about
would
the
like to
solution
keep
itself.
for this question I would like to keep my comments and my minds private.
Okay. Okay.
All right,
Okay.
that's
Thank
it.
you, Alex.
Thank
And
you guys. Don't forget to star us on the GitHub. This is really important for us. You can get this plugin on the from Python repository and come back to the links again. Thank you so much. Thank you for your time and see you next time.
yeah, thank you everyone for joining us. And please don't forget to rate this talk on the community page and give speaker a thank you badge. And on community page, you can download the presentation file and review these materials whenever you want. Thank you, Alex. See
Thank
you
you.
at the next session of Winter Data and AI Meetup. Bye bye.